Okay, welcome back, everyone. I'm very happy to welcome an old friend of Haystack, Doug Rosenoff of LexisNexis, where he's the Director of Global Search Test Tools, including the Search Test Framework and the A/B experiment applications. And he's worked for 30 years in electronic publishing and research, and he holds several patents in search. So he's going to be talking about generative AI search and summarization testing using human SME techniques.
Good morning. Good. First off, I'm sorry if there's glare coming back at you off my forehead. I can't really do much with that, but forgive me and I'll try to move around so it's not obscuring your view all the time. I work for LexisNexis. I'm here representing a team today that's been working on this problem of evaluating generative AI. And our first step into that broad and fairly deep pool was using subject matter expert techniques. And so that team's name is Jupiter, so you'll see lots of images coming from NASA today. But to acquaint you with LexisNexis, it's part of Relics Corporation. You might have heard of Reed Elsevier. That's a part of Relics. It specializes in scientific publication. LexisNexis specializes in legal news and information, as well as general news. There's also several other parts of LexisNexis. One of them is Reed Exhibitions, which is kind of weird. But there's also a risk arm that deals with that. So it's a large company. It's international in scope. We operate all around the world, and we do not just publishing, but also technology things. So productivity, analytics, management, marketing for legal professionals and all that. But at the core of that has always been and continues to be research services for the legal professional. One thing that Lexis takes very seriously is that we believe in advancing the rule of law around the world. And so when we build tools, even at this level, we're thinking hard about internationalizing those for language, for different legal systems and all of that. So that's a big deal and controls a forefront task for almost everything. We've been involved in online publishing, believe it or not, since 1973, when we installed our first private network in large law firms with our own terminals. That predates all of that stuff, and we've been doing it ever since. We've started adopting machine learning and AI in 2019. Some of you may be familiar with our previous efforts in those areas. So just going to give you a real quick overview of what content there is on the spindle, about 3.8 petabytes. So we add a significant fraction of a Library of Congress every month in terms of stuff we get in. That includes stuff that we publish, that we write in the news area, as well as stuff from various government agencies all around the world. There's documents and records content, filings, things like that, as well as dockets, briefs, things like that, and cases, statutes, all that sort of stuff. So it is a vast set of content, and it's a large corpora to work with, and that, of course, makes it interesting and spicy. The goal of the generative AI effort at LexisNexis was to provide customers with trustworthy tools that simplify their work processes and improve their efficiencies. Lawyers, as a whole, are very hands-on, and they tend not to be the latest technology consumers. They like what they know, and one of the things that they know is that they know how to dictate and they know how to type, and so they do a lot of that kind of work. But they recognize more and more that because they're based on an hourly billing model, that for them to be profitable, that anything that improves their efficiency is a big thing. And generative AI is a very, very positive and powerful tool in that way. So as we looked at this problem of taking generative AI to legal practitioners, we divided it into 4 areas: conversational search, editorial content summarization. That's editorial summarization by us, LexisNexis, as well as customer document upload and summarization and document drafting. I'm only going to talk about summarization and search today. So briefly, when a customer does a search into our corpora, they're looking for very specific answers sometimes, all the way down to a document. Maybe their search is 101 SCT 509. They're looking for the case on page 509 of the Supreme Court Reporter, volume 101. Maybe they're looking for, tell me about the laws governing search and seizure in Mississippi or some other state. So it's a much broader question, much more nuanced question. So we get everything coming in. Sometimes it's Boolean, sometimes it's natural language, sometimes it's fielded data. We have to take it all in. So search is a very complex problem for us. And filters can be of use, but they tend to be rather narrow. So we tend to approach this in a broad way. Editorial content summarization. You can think about the vast amount of content we get, and customers are not interested in reading every word. So if you've ever read a patent application or a patent document, it's very dense. And usually the part you're interested in is about half a paragraph on page 13 that talks about one specific thing. So, we need and have to provide summarization of large parts of a document. So even a very large case, for instance, like Brown v. Board of Education, has literally thousands of pages written about it. And you don't want to wade through that unless you absolutely have to and you're a law student. So you go back and you try to summarize that, or you get briefs of that, or summarize parts of law that are in that. So summarization for us is a very important high revenue issue that we need to provide our customers with accurate and trustworthy summarizations. And finally, one of the things that customers really want to do is accurate summarization for them. You can think about when, to take something out of a recent case that's in the news, the defendant dumped over 700 pages on the prosecutors and said, your answer's in this. That's a hard thing to find when you get 700 pages of typewritten text. So customers want to take that amount of information and shovel it into a system and say, summarize this for me, give me the relevant points. And document drafting, we won't go into today, but it's a very obvious extension of AI. So I'm just going to give you some real brief definitions here that we tend to use inside of LexisNexis to be precise in our language. Human relevance testing is, I think, a technique everybody's probably familiar with. Subject matter expert is who does the rating within an HRT process. We use the term ask as generative AI equivalent to search. We differentiate those two because search might be something like a natural language query or a Boolean query or a fielded query that has a very specific direct response, where ask is involving an LLM. Response is just that, the response from the LLM, and it's analogous to SERP. We differentiate prompts into the system prompt, which we craft to describe common features and expectations for the user in the output, and a user prompt, which is analogous to the query in a typical search. So I want to throw this up on the screen, and I want you to kind of take a second to grok this if you can, because this process really underlies so much of what we are going to talk about the rest of today. So this is an HRT testing framework. This slide is about 6.5 years old now, and it's still really relevant because we start with a testing framework that frames up this whole process. And we start with inputs, as you'd expect, query and corpus set, a rating rubric telling the raters how we want them to rate the data. Mainly it says use common sense. We don't tell them to do a mechanical process to say a 4 happens when you get 3 mentions of the search term. Parameters of various sorts, inputs and filters, and then we generate an answer process set. So if this were a search engine, this is a collection of SERPs. You can get that from an API or from scrapes. Those go into a series of rating pages. Those rating pages are rated by somewhere between 1 and 3 raters, and then they produce each one a rating. Combining that information, then we move to calculating results, analyzing correlating trends and anomalies, and then looking at those final results, not only for the problem at hand, but also for the statistics on the rater, or the rater pool, because that tells us whether they're struggling with the task or not. That gives us a good sense of IRR, inter-rater reliability. So a lot of stuff goes on there. So this is HRT. So this is non-AI testing. That's generative AI testing. And you'll notice that it's really the same in so many ways. We started out by letting users test generative AI results, not telling them how, but letting them sort of forge an empirical testing process. We have some very experienced folks that are involved with this kind of testing. And we sat back and watched them for a while. And then we said, what are you doing? And they said, oh, it looks just like the other one, except that generative AI API scrapes are the same. We go through this rating process. We combine the generative AI results. We get an archive. We analyze it, and the results come out. Now, maybe it's a case where once you have a hammer, everything looks like a nail, but we don't think so. Because we turned the raters loose and the supervisors of the raters loose to say, test this empirically first and then tell us how it worked out, and they gave us something like this, we feel like, yeah, it might be another nail, but it's a much different kind of nail and maybe a lot bigger. So basically the takeaway is that standard HRT and generative AI SME evaluations use the same meta process. So that enables you to make some huge strides because you don't have to reinvent the wheel to do human evaluation of results. So initial testing goals, I'm not going to read through all of these. I'm going to highlight a few. Overall, though, you've got a collection of multiple metrics that you have to keep track of. AI results are much more difficult to rate, and there's many more balls to juggle when you're doing that. One of the advantages, though, is if you can settle a set that everybody agrees on, now you've got something that you can use across the company and not just within a group. With a large company operating in multiple countries, that's a big deal. You've got this problem of comparison of generative AI responses where you've got lots of variables to check, but at the end of the day, you have to provide a single tool that can do all that and associate the results in a positive way. And then you've also got this problem of optimizing by corpora. In other words, the LLM or the system prompt or the combination of those two may be very different for statutes than it is for cases, or may be very different for news than it is for cases. So you have this problem of corpora specialization as well. Ask, you've got data-driven decision-making, and this is a real serious problem right now. Comparison of results and regression of results of generative AI results is not a trivial problem. And that's one thing that you have to know whether you're actually improving or not, because you can't just look at it and estimate windage that we're 5% to the right of where we were last week. Also, summarization, you've got two tools here. You've got editorial summaries you might want to check your LLM generated summary against, and you want to explore generation of LLM-based stuff to editorial stuff. So instead of us having to hire another few hundred editors to write summaries of cases in the congressional record, if we can get AI to write those summaries and have 1 or 2 editors go through and find the anomalous ones, that's a much cheaper, more economic tool as long as our customers find that a trustworthy approach. So we settled on two basic metrics. I'm not going to go through these in depth, but we have a simple one. Basic AI metric, we call it the simple response quality metric. And it takes 7 factors and asks the rater to integrate those 7 into a single number, 1 through 4. Now that's an even numbered scale because we want no ties. We want no one to say, yeah, it was okay, because that doesn't tell us anything about what they thought. So you're either poor, fair, good, or great. Now, other ratings outputs, we ask our raters to give us comments. So they may say, oh, this is really hard. I gave it a 3 because, or a 2 because, or they might say, I just don't know how to rate this, and that's okay. This is really useful for reconnaissance and cheap evaluations and fast evaluations. Overall, LLM or generative AI ratings take a long time. They're much harder than HRT ratings because it's not just relevance that they're looking for. They're looking for all these factors and they're balancing together. So ratings may go from 2 minutes to 45 minutes or an hour to an hour and a half, depending on the complexity of the document. This is the basic metric. So we did the first obvious thing for the advanced metric and said, okay, instead of just giving us 1 rating, give us 1 rating for each of those attributes. And so this shouldn't look very much different than the last slide, but now we're asking our raters to say, okay, did you find any hallucinations? Yes or no? Binary response. Was the document useful overall to the query? Did it answer the user prompt? Was the fluency correct? In other words, did this sound like something from a lawyer and not the kid in the basement up the street? So there's a bunch of these. We ask our raters to rate each one of these. And so you can see why this starts to take a while. So now I want to touch base on ask or the generative AI version of search. There are many things to be tested when you talk about AI search in a large corpora, complex corpora environment, but you can't test all of them. It's expensive. There's vast numbers of tests to run. There's not enough raters in the world to do the work that you want. So you have to choose. So the first one is to fix the LLM, fix the corpora, fix the system response, and only use user prompts. Now, LexisNexis historically never uses responses that are generated internally. Queries or inputs that are generated internally. Oh, I'm sorry. We always take these from real queries that are submitted by the user. So we don't filter those, we don't optimize those, we don't use any sort of canned, cooked queries. Those are user prompts coming from end users, end user customers. So we look at those and then we test and measure those responses. These other things, yeah, they're all critical, but not today. First things first, we got to get something out the door. So here's that process again, and I'm just showing this to refresh your memory. Inputs, ratings process, generation of results. So what does that look like when we actually give that to a rater? Well, each rater in that rater pool gets a ratings page. And so there is the prompt up there. What do I need to bring to an attorney for them to draft my will? There's 7 metrics that they assign, 1 to 4, except hallucinations, and that's binary. There's a prompt response. So that's what you see in the text there. And then there's a series of citations underneath. So in law, as opposed to many other things, citations are absolutely critical. They tell you what documents were cited in the one you're looking at. They tell you what documents were citing the documents you looked at. In other words, what do you point to and what points to you? But more importantly, they also tell you is what you're looking at good law, or has it been overturned, or overturned in part and maintained in part? So citations are critical. So we have the opportunity to rate the citations. And then there's opportunities for comments both on the citations and the overall response. Okay. And then the ask output metrics. Well, whoa. So as you'd expect, this is a little more complex. So you get results from each prompt response pair, from each metric and each rater, and then representative sets for each metric and prompt response pair. So that gives you the full view of what all the raters in the rater pool are saying about that prompt response combination. Then you also take an average across the ratings for each metric, get an average rating, you get average ratings for each prompt response, and then we look at major and minor precision. And then finally, as I said, we look at rater completion. So what does that look like? Well, this is an example output. The yellow highlighted information is the data set wide above the fold stuff. And you'll notice for each of the various metrics, it now gives you a rating and a percentage. And you'll notice that we have 2 that say fail and 50 that say pass. So our hallucinations present is 4% of the time. Now, this is the below the fold, and this is now looking at the overall ratings. That was the same as the previous slide, but now you're getting the information about how many errors were reported, how many queries were excluded as part of the analysis, what's been completed and all that. Here's the information about the various raters along the bottom. Okay, and then for the individual results, there's the query up at the top, or the prompt, the response, the overall average results for each of the metrics, broken down by the individual ratings and by the individual rater. So I know that sounds like a huge amount of data, and it absolutely is, because some of these surveys or these studies will run a couple hundred to 300 prompt response combinations. So the administrator that sets these off have to go through those and figure out if there's any anomalous ones. And that's a big part of this job, is figuring out which ones are rated wrong or have an anomaly in some way before you combine and say, yeah, overall, our average is good or fair or poor. So I'm just quickly going to run through summarization here because it's very similar. In this case, the number of use cases is also quite vast. And again, just the simple one, document to summary comparison. So that's where we start. There's also a whole bunch of this other stuff that we can vary and want to test. And again, automated regression series, citation comparison, summary comparison, all those things have to be done too. Should be familiar by now, right? So I'm not going to dwell. But when we do ratings now, you have to give the rater an opportunity to figure out what the summary is about. So the original page, the citator information, and the actual summary that comes back. And at the top, you have the terrible string of numbers up there that's basically a prompt, which points to a specific document. So document text continues. Sometimes these documents are tens or even hundreds of pages long, so these summaries can get to be quite long as well. And you'll notice we have citations listed in there. And we don't have them rate the citations in a summary right now, because really they just need to be whether they're present or not. So again, very simple output. We look at the results from each prompt summary pair. We look at the results for the entire job, and we look at rater completion metrics. the ones for the entire job are the ones where we would start in our analysis. And when we start to see problems, then we go back to individual ones and evaluate whether we want to include those, whether we want to re-rate that one, or some other issue comes up. Is this, can I get a nod if this is making sense, or are you guys drifting off to sleep? Yes, no, okay. Data set results, again, here we are. Same sort of information with the yellow highlight, average scores across the data set, and then broken down by the 4-point, major precision, minor precision. And then below the fold, same sort of information, but now you get some observations. So the admin can come in and tell you, yeah, this was good or whatever, or they can write conclusions out. That's all logged so that by the time this is finalized, we know what the admin had to say about it, what the raters had to say about it, what the errors were, what the averages were, and all that. And then the individual results, again, you get the average for that result, you get the rater information, and you get the citations involved, the prompt, and of course, the response. So that was the preliminary part of the presentation. So I'm glad that you are following me here. So this is where it gets really fun, because at this point, now we can start to turn on some really interesting processes, because HRT as a process is a rich, rich source of information, and only part of it typically gets used. So let's talk about some of those other by-processes. So we talked about comparison process, and one of the things that jumps out right away is there has to be some way to compare this stuff. But an AI response, the same prompt on 2 days in a row can vary. So we have this problem with similarity, and that's a real issue. And we can't calculate similarity is not a trivial problem, because if you want to do it right, you're looking at cosine similarity, and that involves vector transforms, and it's very expensive from a computational point of view. So to do something rough and ready, why not look at the ratings rather than the result? In other words, look at the ratings instead of the metrics. So now look at the ratings in a control set and in a test set, and look at the average that comes across for each query, or look at the average that comes across for each data set. And as long as you do something smart, like look at correlation metrics across all the asks in that set, or all the summaries, then you can do things like correlation coefficients, right, between the ask and the test. So you can now say, I'm getting a reasonably good correlation from this test to this test, or I'm not getting a good one, or they don't have anything in common. But you can now start to say, okay, given this and given this, I can now do this even though they're varying slightly. I don't have to see the word, get a word-to-word comparison before I can make a decision on whether I'm improving or not. Let's talk about regression. Major pain, right? That little trip from metric to rating was huge, because this is the only way you can regress, right? Because now you've got this average and standard deviation that you can calculate on changes to metrics in the data set. So, excuse me, changes to ratings in the data set. So you can now start to look at, okay, on April 1st, this was what I was getting out for an average for the data set. And when I look at all of the ratings, they come in at 3.2 or whatever it is. So I can now start to break these down and put them together incrementally. So I can say, okay, from April 1st to May 1st, when I run the same data set, do I get the same averages? Do I get the same standard deviation across those ratings? And then on June 1st, I can run the same series again and see whether it's staying the same or decreasing or whatever. So now you have a way of looking at regression against a baseline. Now you can, if you've got regression against a baseline, then you've got cumulative regression, right? Because I can start on April 1st and I can use, then when I do May 1st, I use April 1st as my baseline. When I do June 1st, I do May 1st as my baseline. So we've got both now in a very straightforward and trivial way, but it's all based on that recognition that you're now using ratings rather than metric values. Okay, this is where it gets really fun. So one of the big problems, right, in all of this stuff is, okay, so I've rated a bunch of stuff. How do I make use of that in a broader way? So in a large company like ours, we have content workbenches, and we take content in and we use it in various ways. We mark it up, we partition it, and all that. And normally that's the problem of some scripts and some grossly overworked editors and programmers. If we have ratings that we already know for that summary, for instance, that are everyone agrees that's an awesome summary, then we don't have to go through that step. We can push those great summaries directly into the content bench and say, this has already been graded, guys. All you have to say as an editor is, that's good. Push it on out to the content system. So it allows you to now leverage the AI in a virtuous circle here from the test through the ratings, in other words, getting the information about the test, the results, and then pushing that on out into content systems. So a nice example of a virtuous circle here. If you then go ahead and watch what the customers do with that same summary and ask them if they like it, yes or no, and they tell you yes, then this just runs faster and faster. So this is a great example of a byproduct that was really quite unanticipated. Obviously, the problem of gold rating results is a big problem when you're doing generative AI. Cheap, free, fast gold results here, because every time you do a study, you take those optimized results or those high value results that come out of that, and those are gold results for you. Your raters are telling you that those are the best that they've seen. So that is an easy, fast input source for gold results. So if you want to optimize using those back into your data set, then you've got that. Okay, so pulling into the end here, lessons learned. SME evaluation is a highly accurate tool, and it requires a scalable tool. You don't do this on 10 searches or 10 documents for summarization, because it doesn't give you the stats to do this. It takes a lot, and it takes a lot of raters, and that means it's rather expensive and rather time consuming. You really want these studies to take a minimum amount of time, so that means you got to hire a bunch of raters to do that. They have to be subject matter experts. You can't hire the teenagers off the street to rate legal documents. SME evaluation is a process, transfers easily and successfully to generative AI evaluation. So I think you've seen that now, that the same meta works in both spaces. It's just a little shift in mindset. Generative AI ratings require more SME expertise and take longer. So we found, going from just a couple minutes, 2 to 10 for HRT studies, sometimes for an advanced study with all of those 7 metrics on a long legal document, it might take 2 to 3 hours for a rater to get through that entire document. So fatigue becomes a big issue, which means you have to have more raters. Generative AI as a testing problem is complex with both quantitative and qualitative aspects. There aren't a lot of generative AI metrics that are standardized. So this was our first attempt at it. We look forward to seeing what the industry comes up with, what the academic space that comes up with, but these work well for our environment. Your mileage may vary. I saw a really good talk from Moody's about their metrics, and the way they've adopted things is very different than this. And so their metrics are very different. Generative AI methods spin off free byproducts. I wanted to just call your attention to sort of some ending comments about generative AI that are not maybe obvious. And these first 4 results here in the outro are about trust, right? Right now, there's a huge backlash against AI in the image space. And I fully anticipate that we'll have that kind of backlash in the document space. Because how do you know when you're looking at a string of words, whether an AI generated or a user generated it? How do you trust that? And when you have a content business, the business is based on the customer having trust. They can count on, this is what the judge said. This is what the legislature enacted. This is what the statute is for smoke particulate in the air. So you have to be aware that users are going to be very concerned in comparing old style results with AI results, because they're going to want to establish that trust. They may be faster, they may be sexier, it may be the coolest thing to come down the block. People say it's the best thing since Gutenberg, but if you can't trust it, it doesn't matter. So those first 4 are all about trust. AI testing is complex. It's combinatorial. Things like multiple and complex documents. Some legal documents are literally 3-ring binders. Consider the beige book that comes out from the Fed. That's a 3-ring binder. Doing a summary of a 3-ring binder is not the same problem as taking a court decision in via fax. So lots of different problems with complex documents when you talk about summarization. In the search space, you've got a similar difficulty problem with multi-turn conversational inputs. The first one is easy to evaluate, but when you've got 3 in a row, then you have to try to figure out context, you have to figure out intent. That's a much different problem. So again, this gets up on steroids really quick. And then comparison and regression becomes a really interesting problem, as we've talked about already. Finally, one of the things I think that's probably not obvious, but we really, as an industry, need to think about, is that metricizing and testing Gen AI is also a qualitative exercise. We talked about trust. We talk about intent fulfillment. We talk about conversation satisfaction, context fit. All of those things are about the individual user experience. They're not something like DCG that's easily metricated. So P of K and recall at K and all those sort of things, it's not going to help when these are the kind of things that the customers are judging us against. In the past, that hasn't been a big deal because there was only one response, the search engine, right? Now you can get to that from a variety of ways. So understanding that Gen AI is as much qualitative in the long run as it is quantitative is something that we as testers have to understand. So next steps, lots of work. Oh my God. Additional content types, additional use cases, additional products, Gen AI SME-based byproducts, customer feedback process integration, AI-specific test and metrics, multi-document summarization, multi-turn conversational, and a lot of other stuff that I don't have time to dwell on today. So that's a quick summary of subject matter expert evaluation of Gen AI content. So with that, I want to thank my team. They're fantastic, and I'm privileged to lead them. We have some very dedicated test customers that know the tool as well as the data, and so they make it a lot easier to test. So I want to thank them. If you have any questions, please feel free to email me or phone number. And finally, if you want to work on this for the greater social good, here's an opportunity. We're hiring. So thanks very much. Yeah.
Thank you so much, Doug. And the mark of a true professional presenter, he finishes exactly on time. So we've got time for some questions from the room. I see somebody I vaguely recognize at the back here, Mr. Eric Pugh.
Glad I got in quick. So now that you've added these more, I don't know, rating factors, right? Have you experimented with having other types of raters focus on specific types? Like you talked about like the language structure or those. Can you break up that problem, or does every rater have to do all 7 factors?
That's a really good question. And to be honest, it's not something we've considered. For the most part, we've said we assign a document or a summary or a result to a rater because we're looking for consistency of result. We give the same advice to all those people about what a rubric is. But, you know, having said that, there's no reason that we couldn't have someone look at fluency separately than something else. There's no reason. Certainly, one of the obvious things that I didn't talk about today is going through and looking at the citations with a script to see whether they actually exist or not. There's all sorts of optimizations like that we can do, but we haven't yet. But great question.
Thank you. So we have a question from our online audience. We have Todd Peters, who has a question. A hypothesis, the more you use an SME for this, the less of an SME they become over time. Can you talk about team dynamics, burnout, and reasonable scale throughput if a company wanted to do the same as you from scratch?
Yeah, that's a good question. And one that is not a trivial one. Our raters have other day jobs within the company. So they may get a certain number of hours a week to work on this, but they are not professional raters. So they are expected to maintain their expertise in whatever it is that they do, whether it's you know, editorial work or whatever. So the burnout tends to be less because they don't get to do this all the time. In terms of team dynamics, it's pretty good. I mean, it's we don't say thou shalt complete 24 ratings. We say you can do up to 25% in this study. And so the rater chooses how much they want to do or how much they want to spend on it.
Thank you. That's great. We have I'm just going to go to this chap up here.
Thanks for the great talk. My question is around how do you measure accuracy within the context of the document? Because I imagine that's super important for, I mean, that's why legal documents are so dense and long, is that there's just so much we need to define and so much context that we need to lay down before. And then you were saying that earlier that like something that the user might be looking for is just one piece in that whole document, right? But how do you evaluate whether that piece that you retrieved and summarized is actually accurate within that context? And
right.
Yeah.
A good question. And again, we rely on raters to use their common sense. All the raters are attorneys. So we anticipate that they know a good legal response from poor one. So in terms of accuracy, if it, you know, they have the original document, for instance, if it's a summarization, they can go back and look at that and compare toes to toes if they want. They certainly, everything is densely hyperlinked in our environment, so they can always refer back to the reference document. So we give them plenty of tools to make sure that they are very accurate. But we don't, again, do something didactic and say, it takes 5 hits of this word before you give it a good.
Thank you. Tito.
I was very interested in your 7 advanced metrics. How did you land on those 7? And then have you found that having run these tests, that some are more valuable than others?
Yeah, that's a really good question, Tito. These 7 came out after extended discussion and a lot of reading. This was a company-wide effort, and so it wasn't just our team saying these 7 seem most reasonable. Some of them are very obvious, like fluency, hallucinations, those sort of things. Others of them are more ambiguous, like utility, and those are more summarization. So again, that's why we have a simple metric and a complex one. We allow people to adjust for those. In the simple space, we just say, give us a sense for the overall. And in the complex one, we want information about each one of those. Can they be improved? Yeah, absolutely. First cut, first year of using them, yeah, we're not, but the fortunate thing is, and the good news is, we're not seeing a lot of demand for other metrics. This is enough to accomplish our goals.
Okay, I think we have time for one more question.
Thank you. So my question is more about what basically the feedback loop from all of this data. You're generating, as you mentioned, these gold standard summarizations and just honestly a wealth of data, I think, compared to some of what a lot of us get to see day to day. Is the ultimate goal to, compare models, open source models? Is the goal to update prompts for these generative AI tasks? Or are you down the road thinking of, fine tuning and building a larger model, or is it just all the above once you have it?
Yeah, exactly. All of the above. These byproducts are fantastic because they give you information that you didn't expect to get. But the overall product or the overall goal is evaluation of the tooling that you've selected. So LLM, system prompts, all of that. Are you trying to improve those? Are you looking at improvement over time? So the basic goal and the overriding goal is always, are you improving what we're giving to the end user? The nice thing is lots of byproducts come out. Thank you all very much for the privilege of speaking today.
Wonderful. Let's thank Doug Rosenoff.